Hi guys, Miss Powell here. Today we're starting a new unit. This is Unit 6. We're starting with the lesson volume of prisms and cylinders. First of all, this is called a triangular prism, the shape that you see to the left. We know that this is a triangular prism since the shape of both bases are triangles. The bases of a prism are always connected by a perpendicular line segment. So if you are wondering, how am I going to know what's the bases? These two are, in fact, the bases, these two triangular portions. Number one, bases are always 100% of the time parallel to one another, so that's your first clue. Your second clue is that they're always connected by a perpendicular line segment. We're going to go ahead and call it H for our purposes. We can find the volume of any prism by using the following formula. So no matter what's the shape of the prism, we can use this formula. V is equal to big B times H, where B is the area of the base. Big B is the area of the base. H is the perpendicular distance between the two bases. All right, looking down here, these two figures that we see are called cylinders. One is a right cylinder and one is an oblique cylinder. The oblique obviously looks like it's been kind of shoved over to its side. However, we can find the volume of each one of these cylinders regardless of whether it's right or oblique by using the same formula that we saw above. V is equal to big B times H, where B is once again the area of the base, H is the perpendicular distance between the two bases. Being mindful, right, that this cylinder has a circular base. Therefore, obviously the area of this base is going to be pi r squared. All right, moving down, we're going to look at something called Cavallari's principle, and what it says that if two three-dimensional figures have the same height and have the same cross-sectional area at every level, then they have the same volume. So, with respect to what we just saw above, a right prism and an oblique prism with the same base and height have the exact same volume. So what's important for us to know is the perpendicular distance between the two bases. All right, looking at example 1, we are asked to find the volume of each prism. All right, so looking at this one, first thing that we want to find is the area of the base. Please be mindful that our base here is, in fact, a rectangle. So the area of a rectangle we know is length times width, so 16 times 4 is going to give us the area of this base, which is 64 centimeters squared. To calculate the volume, we're going to take the area of the base, we're going to multiply it by the height, which is 9. Therefore, our volume here is 576 centimeters cubed, because we're talking about volume and not area. Make sure you have that cubed on there. Looking at number 2, you might be wondering, how will I know what my bases are in this figure? Well, be mindful. Rectangle is not your base here, guys. Your base are, in fact, triangular figures here. So if I want to figure out the area of my base, big B is actually going to be equal to 1/2 base times height of that triangle. What we end up with is 15 halves. To figure out our volume now, we'll take the area of the base, which is 15 halves, times our perpendicular height between the two bases, which is in fact 8 units. So 15 halves times 8, we end up with 60 inches cubed as our volume. All right, moving on to look at the volume of a cylinder. First thing we want to do, obviously, is find the area of the base. Remember, our base here is in fact circular, so pi r squared. 64 pi is the area of our base. You do not want to approximate that pi until we get done with our volume, and then we'll go ahead and write our final answer written and rounded to the nearest tenth, as well as expressed in pi. Our volume here is equal to the area of the base, so 64 pi times the height. Calculating this in terms of pi, we have 640 pi, which is approximately equal to 2010.6. Of course, we're talking millimeters cubed. Calculating the next cylinder, what we see is that this cylinder is oblique. However, we're going to treat it the same way since we know the perpendicular distance between these two circular bases. So the area of our base is pi r squared. This gives us 9 pi. Calculating the volume, that's going to equal the area of the base times our perpendicular distance between the two bases, which is 5. Our volume here in terms of pi is in fact 45 pi. That is approximately equal to 141.4. Of course, we're talking feet cubed, right? Because we're dealing in volume here. All right, so looking at questions number 5 and 6, the directions ask us to describe the effect of each change on the volume of the given figure. Well, here's the interesting thing. This particular figure here we see is a box. So if I go to calculate the volume of this box, that's equal to the area of our base, which is 7 times 2, which our height is 5. So multiply 7 times 2 times 5, and we end up with 70 inches cubed. However, as an experiment, if I multiply each one of these side lengths by 2, what I then have is 14 times 4 times 10, which is going to give me 560 inches cubed. So what we see is between our original volume and our new volume, when each one of the dimensions are multiplied by 2, is we see that the volume is increased by a factor of 8. Or we could also say that the volume is 8 times as large. This is not coincidence, by the way. We know that volume is measured in cubic units. So therefore, if each one of the sides is multiplied by 2, I could take 2 cubed, and then what I find out is, in fact, my new volume should be 8 times as large as my original, and that is in fact the case. So looking at number 6, if I want to describe the effect of change on the volume of the given figure, what I can see is that if I'm going to multiply each side by 1/4, I can take 1/4 cubed, and that gives me 1/64. Therefore, the new volume of this figure, when my dimensions are multiplied by 1/4, should be the volume is, we could say, changed by a factor of 1/64. All right, going on to our last 2 questions here. Our directions ask us to find the volume of each composite figure round to the nearest tenth. All right, so the first thing that we want to consider here is the volume of the box. So to consider the volume of the box, I know that V, I'm going to say of the box, is equal to the area of the base, which is 10 times 5, times my height, which is 3. This is going to yield, let's see, 150 meters cubed. Okay, 150 meters cubed. Now I want to consider the volume of the cylinder. The volume of my cylinder, I'm going to consider the area of the base, so pi r squared times the perpendicular height between the bases, which is 4. 4 times 4 is 16 pi. All right, so the last step that I want to do here is I want to consider my total volume. To find my total volume, I'm going to take 150 and add 16 pi to that. When I do that, and I remember, per my directions, I want to make sure that I leave this rounded to the nearest tenth. I am approximately at 200.3 meters cubed. All right, looking back over here at number 8, with number 8, I want to follow the same logic, right? The first thing that I want to consider is the volume of the larger cylinder. So I'm going to say volume of the large cylinder is equal to pi r squared times our perpendicular height. So this gives us 27 pi. All right, so my volume of the large cylinder is 27 pi feet cubed. Now I want to consider the volume of the smaller cylinder. So I know the area of my base is pi r squared times my height. So we end up with about 8 pi on that guy. So now I want to calculate the total. My total is going to be 27 pi plus 8 pi. Remember, we have to round per our directions. So rounding, what I end up with is about 110, and we're talking about feet cubed. All right, guys. Hope you have a great rest of your day, and we'll see you tomorrow.